ஸ்டார்ட் பண்ண
Mano, you able to hear me?
Yeah. Oh, clear.
I'm not able to hear you.
Yeah. Now, how about now?
Hello.
Am I not audible to you now? Hello. Hello.
Mano, you able to hear me now?
I'm able to hear you very clearly.
But I'm not able to hear you.
Sivakumar, sir?
we are able to hear you. We are able to hear you. Chris, I am able to hear you.
Yeah. Okay. Sriram, sir, I'm able to hear you very clearly, sir.
Sriram, sir, are you able to hear me?
Yeah. Now is it okay?
Yeah, we are able to hear you, sir.
Mano, you're.
Yeah, I'm able to hear you clearly right from the beginning.
I'm still not able to hear you. I don't know why. I'm not in mute. 1 second.
Maybe you have to increase the volume.
Hello.
Yes, sir.
Yeah, we are able to hear you.
Yeah, now I'm able to hear.
Now it's over. Now it's okay.
Yeah, now it's okay. Yeah.
Fine.
Okay, Mano, what I would request is that you introduce Mr. Sivakumar and also tell everyone to type in their questions as he goes along. Let's not disturb him, but they can type in the questions as they go along, so that you can collect those questions and
address it to Mr. Sivakumar at the end of the session.
Yeah, at the end of the session. And I think Sridhar and Lavanya wanted a 1 minute vote of thanks also at the end of the thing, which I think Raja of NMAC will do it from the Ref Cold.
Fine, sir.
Lavanya, is it right? Raja is there?
Yeah, I have informed Raja. Yeah.
Yeah. Okay. So Sridhar, so shall I go out with the introduction and the thing? Yeah. Okay. Fine. Okay. We still have 3 minutes to go.
Yeah, three more minutes to go. Let's start by sharp 5 o'clock, sir.
Yeah, and the total this thing we will have 1 hour. We will have Mr. Sivakumar. It will just be 2-3 minutes of my speaking at the beginning, and then we have a Ref Cold video which we will play for 2-3 minutes. Then Mano will introduce you, and then you have about 40 minutes, and at the end of which, depending on the time available, we will take questions for about 10-15 minutes. The balance questions, if you want, you can pass it on to Mr. Sivakumar, and he can ask, he can reply to that offline.
Okay.
Fine, sir. Perfect.
Okay, fine. Let's wait for a couple of minutes and start at 5.
Sure, sir.
Okay.
You have roughly 10% of the participants logging in. 27 participants as of now.
Yeah, I think that's the advantage or disadvantage of a virtual meeting. I think we'll have to learn to live with it.
Yes, Gokul. எல்லாம் ரெடியாக நீங்க இருக்கீங்க லாகின் பண்ணிட்டீங்களா ஓகே ஓகே நாங்கள் முன்னாடியே வந்து மண்டபத்தில் எவ்வளோ காத்துருக்கோம் நீங்கள் கேட்குறீங்க ஓகே தேங்க்யூ பை
Sriram, I just sent you a message, Sriram.
Regarding? One second. Yeah, okay. Yeah, shall we get started?
Yes, sir.
Yeah,
Yeah.
good evening, everyone, and thank you for joining us in this series of webinars which we have planned leading up to RefCold 2023. Today is World Refrigeration Day, and I'm sure just like me, all of you have been bombarded with a lot of WhatsApp messages and mails asking you to participate in various seminars. And I think that is one of the reasons why, although we got about close to 250, 260 registrations, only 30 of you are still there. I hope as we go along, we'll have more people joining in. Sridhar has also sent me a message, and I was actually wondering, suddenly there was so much this thing, brouhaha on the World Refrigeration Day. I just wanted Google to find out what exactly it was. And Google tells me that World Refrigeration Day is celebrated on the June 26th of every year. I think it's Saturday somewhere in 2019. It was the birthday of Lord Kelvin, who's as all of us know, a refrigeration pioneer. And this is being conducted. There is a World Refrigeration Day Secretariat based in England, and there's a World Refrigeration Day website. And this is basically a day the idea of the day is to was developed by a refrigeration consultant named Stephen Gill, who's from the Institute of Refrigeration, UK. The idea was to raise awareness about refrigeration technologies and everyday life, and to raise the profile of the sector in general and also professionals in this field. I'm sure all of those participating in today's seminar are from the refrigeration industry. So on behalf of the RefCold committee, greetings to you on the occasion of World Refrigeration Day. This seminar is actually a second webinar, is actually a second in the series of webinars which we are planning leading up to RefCold 2023, which is South Asia's largest refrigeration and cold chain exhibition. RefCold is conducted every year, and the 6th edition of the exhibition will be held between the 12th to 14th October of this year at the Chennai Trade Center, Chennai. An exhibition of this magnitude is coming to Chennai after nearly 25 years. The theme for this year's exhibition is Preserve Through Innovation for a Better Future. We expect to have nearly 200 exhibitors from the refrigeration industry to participate in this exhibition. We have actually planned a webinar for every 15 days leading up to the exhibition, and this is, as I told you, the second in that series. I request all those of you who are here to participate in RefCold 23, either as exhibitors, if you have something to exhibit, or surely come in and visit the exhibition on the days which I mentioned. And for those of you who are doing refrigeration projects, I would request you, we have two interesting items running parallel along with RefCold. One is a seminar which runs on all 3 days by reputed international speakers. And also we have RefCold Awards Night, which is sponsored by Copeland, where exceptional refrigeration products and products can be displayed. I'd request all of you who are interested to please participate in the refrigeration awards night, which will be on the first day, on 12th. So please visit the RefCold website. In case you want to have any further details, please use the chat box in this webinar and give us your contacts, and we will reach out to you. The agenda for today is that after my speech, we will have a short video on RefCold, After which Mr. Mano Krishnamurthy will introduce to us today's speaker, Mr. Sivakumar. And after Mr. Sivakumar finishes, we will have a question and answer session, after which we will have a small vote of thanks session. Over to Lavanya for the rough cold video.
Sivakumar sir, you can stop your screen.
Okay, sir. I have done that.
Okay, thank you so much. Lavanya, are you able to do it? Okay.
I am not able to hear the audio. I hope others.
No, the audio is not there.
Give me a sec. I think video is not coming. I mean, audio is not coming. Lavanya, can you stop? I will share. Can you stop it? I will share. Please stop it. Stop and share. Stop sharing. Become video visible? Sound?
Yeah, I'm able to hear.
With the exponential growth in the Indian cold chain industry, it has been termed as a sunrise sector. Still, India faces an acute problem of appropriate refrigeration facilities, leading to 1.3 billion tons of food perishing in India. With a large spread of arable land, India is the world's largest producer of milk, fruits, vegetables, seafood and meat. Over 80% of the cold chain industry in India is unorganized and uses outdated and archaic technology, resulting in gross inefficiency and food loss. The cold chain industry is expected to grow at a CAGR of 14.3%. With the advent of food delivery, favorable government policies and innovative technology. With this market growth potential in perspective, we introduce South Asia's premier refrigeration and cold chain exhibition, Ref Cold India, which has a rich legacy of connecting experts and which enhances opportunities. After successful editions in Ahmedabad and Hyderabad, Ref Cold India is all set to catalyze the growth from the 12th to 14th of October 2023 at the Chennai Trade Center. With a coastline of almost 1100 kilometers, Tamil Nadu has been identified as a champion sector for boosting exports and helping the state realize its goal of becoming a $1 trillion economy by 2030. Ref Cold India is a state-of-the-art exhibition positioned at the very horizon of innovation. Key progressive innovations of the industry will be on display, with insights by the decision makers. With over 200 exhibitors, the exhibition would feature an innovation zone and a B2B networking area. Ref Cold India caters to industries such as fisheries, agriculture, horticulture, pharma, dairy, poultry, food preservation and reefer logistics. The Ref Cold India Awards Night will highlight and honor those at the forefront of this burgeoning industry. The Indian Society of Heating, Refrigerating and Air Conditioning Engineers is an organization dedicated to the advancement of the arts and sciences of the HVAC industry. In former markets in India, is known for its expertise across the B2B exhibition sector and its ability to create innovative business platforms. It has collaborated with the Indian Society of Heating, Refrigerating and Air Conditioning Engineers to present Ref Cold India 2023, South Asia's forefront exhibition for the refrigeration and cold chain industry. We invite you to join us in Chennai from the 12th to the 14th of October for Ref Cold India 2023, South Asia's premier refrigeration and cold chain exhibition.
Yeah, thank you. And request Mano Krishnamurthy to take it forward.
Good evening, everyone. It gives me a great pleasure to introduce Mr. Sivakumar Ramasamy to you. He is our speaker for this evening. I had the privilege of working with Mr. Sivakumar during my career days. Sivakumar is basically a MTech refrigeration engineer from Anna University. He passed out in the year 1992, and he has over 30 years of experience in the field of refrigeration. His expertise area is into design, installation of pump feed system, food process refrigeration, supermarket refrigeration, cold rooms, and special applications as snow parks, blast freezers, pre-coolers, pharma, and cold rooms. Few of his projects are Ferrero process hall cooling with 10,000 pallet store, a potato storage of 10,000 metric tons, and so Snowman has got 42 stores, out of which 32 stores are designed by him, and the project was executed by him. Pika Kitchen Refrigeration, Walmart, Reliance Hyper, Lulu Hyper, you name any, his contribution to the success of the refrigeration system in these supermarkets are there. He has worked with many leading companies like Alpha Level, York, and Carrier. Presently, he is the director technical at Asha Ventures Private Limited. I am delighted to introduce Mr. Sivakumar to you. Mr. Sivakumar, it's all yours. Over to you.
Thank you, Krishnamurthy. First of all, good evening, everybody. Hope I'm audible and my voice is very clear. Just I want to confirm this.
Yes, sir, yes, you are.
Okay. So can we start the presentation?
Yes, please go ahead.
Okay. Okay. Are you able to see the presentation, sir?
Yes, sir.
Okay. So basically, today's topic is about the refrigeration for bulk stores. So bulk stores, generally, we know, as we have seen, and we are all aware of India being biggest producer of lot of produce. Okay, if you see, India is the biggest producer of milk, pulses, fruits like mango, lychee, apple, and vegetable like brinjal, okra, and tomato. And if you see specifically okra, India is one of the leading producer and exporter. And in terms of fruit, mango and lychee, if you see, India is one of the country in the world which exports major. And this is the country which grows mango and lychee as compared to any other country. We have the highest output in terms of production. And in terms of pulses, like name any pulse, we have the highest quantity of production, rice, wheat, sugarcane, and marine products, because we have a long coastline, and we name it in egg, poultry, and
Sivakumar,
meat.
sir, your voice is slightly not audible to many of the audience. If you can increase your volume, it will be better, sir. Or if you can.
Okay. 1 second. One second.
So only the audio, sir. Only audio. You can check. You can be a bit louder so that it just be clear. That's all.
Okay, okay.
Only audio. Otherwise, nothing.
Only audio. Okay.
Only audio.
Yeah. Okay. So if you see the food produced, we have two problems. One is the food loss, which is lost during the production due to weather, labor, and quality, and the harvest time wastages. And next is the losses which happens during the post-harvest handling, storage, transport. And third is the packing and the processing area. If you see lot of products in India, still we are in nascent stage in terms of packing and processing and sending it to the market. So with there again we find a lot of losses. And the next comes the distribution losses, which is majorly due to the wrong handling, wrong storage, sometimes practices, and sometimes non-availability of a quality storage area, these kind of things. And the next classification is food waste, which is nothing but the food which is wasted during the consumption, like the portion served or people wasting it due to various reasons. Okay, and third is buying pattern. You buy in bulk, and you have to buy in bulk certain items and which you don't use. So some of the items get wasted and like that. So there are two major classifications, which is food loss and food waste. And majorly we talk about food loss. How do we address this? This is one area which is the focus. And food waste, of course, there also we can contribute. But the major topic today, we will focus on the food loss on the first part. And if you look at the statistics, they say 33% of the food is wasted in total. Okay, if you see what is the percentage of loss and waste, is almost 50-50. Okay, almost 15%. If in this 33%, 15% is lost in the first stage, and second 50% is wasted. And a rough estimate which says that if you value this total loss, it is almost 1 lakh crore per year, which is a huge number. And the result of this, it is one of the highest greenhouse gas emitter, because the amount of food wasted, it uses a lot of resource like water, land, energy, labor, and capital. So any amount of saving done here will have a direct benefit and will give us these potential resources which can be used in a better way somewhere. And if you read through one more statistics which says that 1 in 10 in the world don't get proper food. So these are important numbers which says that there is a need to reduce the food waste, and whatever possible ways, whatever possible steps taken will improve the overall process and will reduce the waste of resources, as we can see. Chris, am I audible now? Or
Yes, sir, very much. Please go ahead.
okay, yeah, thanks. So the next important what we see is that what is the reason? Okay, if you see the major problem is the food gets spoiled because of the physical nature, where we have moisture, and second is temperature. Okay, which is by nature, you cannot do much about it, because every product has its own percentage of water content, which gives food and energy to all the living organisms, and it attracts a lot of living organisms, which can create the spoilage. And the microbes which are already present inside, like mold, yeast, bacteria, virus, and these are n number of things which are there. These are living organisms which will decay the product or spoil the food. And third is the chemical reaction like oxidation, hydrolysis, which takes place within the food. So major categorically, if you see, there are three major categories we can classify. And what this does is increasing microbes, and it destroys the chemical composition, the texture of product, and it spoils the taste and aroma, which is a major factor for food to reach the market or the buyer to attract. And third important is like in certain special item, like special food, packaged items where the nutritional values, which are very important, or there may be some specialty food like food items which are used for the sports personnels and those kind of things, and in medicines and medicinal items, where the nutritional value is very important. So food spoilage changes these parameters. So any of these three forms contributes to this. And what are the factors involved? Various factors. Even if you see the microbes, we have a number of microbes, the majority like algae, fungus, and these things. So the problem, if you look at, is plenty. The reason for the problem is many-fold. So how to attack, and what are the what do you call areas we have to work on? The one of the methods what as human we developed is the preservation. So here again, major classification wise, if you can see chemical processing by adding preservatives and fermentation. Recently, curd and cheese and these kind of items, which are a very big market today. Addition of preservative and fermentation. There are some limitations in this area, but still, this is one method used for certain kind of products. And thermal processing, like pasteurization, sterilization. The milk we consume undergoes this process, pasteurization and sterilization milk, we use steam milk. So these are all processes, which is a thermal process. And next is what we talk about, chilling and freezing, which is the refrigeration aspect. So here also, we address upon what are the type of products can be used, where it can be applied. And the next comes drying. So drying is also a very big activity where a lot of food gets dried and stored as a dried product. The advantage is after you dry it, it is very easy to carry the product through the product life cycle with minimum cost. But the limitation is every product cannot be dried, and the drying also removes, or the product loses a lot of fine aroma in the process of drying. And in terms of non-thermal irradiation and UV radiations, which is again used in certain products, and it is a very little risky procedure, but people do that also. Okay. So as we have seen in the previous slides, we have seen there are a lot of contributors which result in the spoilage of food. And now, when we come to the solution, we have an excellent solution. What is that? We have one technology, which is nothing but refrigeration, which can give us a variety of solution, which can be applied to a variety of products and to address these multiple issues what we have seen. That is the beauty of this technology. So majorly, if you classify and look into it, if you have chilling where you can pre-cool products. Example is like fruits and vegetables, banana, for example. From India, the major export is your grapes, banana, lychee, apple. So all these kind of fruits can be pre-cooled. Okay, and cold storages, as we all know, by looking at the terminology itself, the variety of products goes into it. So even though you look at one single technology, which can be adapted to multiple products to address these issues. The next come freezing, where we have blast freezing, IQ, plate freezers, and freezer rooms. Here also similar. Certain products can be blast frozen, certain products can be done through IQF, and certain bulk freeze can be done through plate freezers. Even Goa, these kind of things are done through plate freezers. And next comes the freezer rooms, where we store the final product, or if you want to do some slow freezing process, you can do those things like butter. They directly go into the freezer rooms instead of doing blast freezers. And third is if you look at the direct chillers, where you can directly chill liquid in terms of bulk milk coolers. If you see the water chillers, juice coolers, dispensers. So all of these are examples where you can directly cool the product. So one technology which fits in or solves a lot of these problems. What is the advantage? It's very obvious. Okay, it reduces the loss. It minimizes. Okay, it cannot stop, but it can reduce it. And the best is one, if you have a pre-cooler room, you can pre-cool banana, you can pre-cool lychee, you can pre-cool any other product which suits. Maybe slightly you have to adjust temperature, but you can apply that. Similarly, you have a cold room, you can use it in multiple ways. Multiple products from dairy to vegetable and fish can be used. So that is the main advantage here. And next is it preserves the chemical composition, and not only that, the amount of preservative you will use will reduce. Certain amount of preservative is must, maybe people use that, but still, as compared to storing a product in an ambient condition or a high temperature condition, when you put them into a refrigeration cold rooms, or maybe through a chilling process or a freezing process, the amount of preservatives can be reduced to minimum acceptable level, because there are a lot of norms which restricts the preservatives and amount of preservatives, which can be easily met using this technology. And as you know, taste and aroma, to greater extent, it preserves that, and nutritional values certainly. What is the advantage is that by following certain procedures and process, they have set up norms by which they are able to get a certified product. Like if you look at the pharma is a very important example. When they say that you store the vaccines at 2 degrees, they store it at 2 degrees and they declare they can give this much of efficacy, which is an important example where we can see this technology delivers a desired result with one technology for various products. This is a symbolic representation for easy understanding. I think people in the trade knows that for benefit of others, it shows the various components, major components, and how they function. Okay, the basic components we will explain in the next slide. This is just to give you an animation. And as we have discussed, where all does this technology touch, or where all do we have the usage for this technology, or where all we practically see this technology is used in the entire product life cycle? If you see from the processing plant, where they do primary processing like food processing, meat, poultry processing, seafood, dairy, where the primary product from the producer is getting preserved or converted or processed to take to the market. And next stage is where you store the products for a certain period of time. So we extend the shelf life so that it reaches the market when there is a demand. And where there is an excess supply, it can be stored. So the advantage is it acts as a flywheel where you store the products during the bumper harvest or during the harvest season and supply that during the non-available time or the off-season time. And transport requisition, today with the connected world, we have producers traveling across the world, and we have reefer containers which goes on the ship. Okay, they transport food across the world, even pharma products and special seeds, they travel across the world, and reefer trucks for the land transport. And next is the commercial refrigeration, where we have the displays and what is used in the supermarkets, hypermarkets, and household refrigerators, the final class. So this is a broad spectrum where this technology gets practically used, and we see them. This is a picture representation to have a easy or a visible understanding of what are the requirements of temperature. Generally, fruits you start with banana, and above them are the products which are stored in ambient conditions for a shorter lifetime. And banana up to 17 degrees, and then all the chilled products at 0 degree, and certain preserved product at -10 degree, and frozen food like ice cream and frozen meat, they are at -20 degree. And -40 is for any of your blast freezing application for faster cooling. And as we discussed, or as I was talking, these are the major components what we use, starting with the compressor units, where we have one-to-one split units, like condensed unit, we call it as. And below this, we can see these are all the multi-compressor bigger systems. Indoor units, which does the cooling inside the rooms. And next is the automation or maybe the controls. The main, if you see a typical cold room, you have a puff panel and doors, which is the envelope for that. And next is a basic small detail about what is the recommended thicknesses used in the market, practically used in the field. For a room of 2 to 8 degrees, 60 mm thickness panel is used. But sometimes if your room height is more, okay, you have to increase the thickness for the vertical stability. So if your room is more than 3 to 4 meters, it is recommended to go for a higher thicknesses. So when you have an exact discussion with your panel vendor, he will suggest you based on the geometry and configuration, type of support you are using. So thickness will slightly change according to that. And what is the advantage of this insulation? What we use today is called as puff insulation, insulated panels, ready-made panels. It has good insulation property. Second is it's a factory made. You can produce in bulk and stock it, transport it. As per the need, you can use it at site. You don't need to wait for the site to be ready. You can be produced before and delivered to the site. So you get a consistent quality, and it's an economical solution overall. If you look at the 15, 20 years before, people used to do mostly civil constructed cold room with insulation, EPS installations. Then certainly they went to puff. Like that, it kept on changing. Before that, they were glass wool insulation. So then they changed to EPS or thermocol. Now people are using puff insulation, that is prefabricated panels. So this is the advancement what has happened in the industry. As we have seen, I have seen EPS panels, and the next generation will see only puff panels. And there is a the suspension limit which is given. Again, this is just a guideline numbers based on your project or maybe your site configuration. It will keep changing slightly, here and there, plus or minus. So if you look at what is the little limitation in this, if you have a high wind velocity in your location, it has to be taken care. Maybe additional supports. Maybe you have to increase the thickness. And if you look at a traditional normal dry store, the entire store is used, but in a cold store, the space above the puff panel is determined. That is what maybe a little amount of volume reduction happens when you do a cold room in a traditional room. And if in case of any impact or local damages, we have to change the pan in the full length of panel, which is if you have other kind of EPS, we can chip it and repair the portion. Here it will be little big repair work. These are the slight disadvantages. And if you classify overall the variety of cold rooms based on the size, what we call, basically our focus is on the right-hand side where we have this bigger application. And if you look at the left-hand side, we have the small cold rooms and the special rooms, which we are not discussing about the like glass freezers. And the bulk cold rooms, or we call it as the large cold rooms. It starts from mid size, where maybe 500 metric ton plus. It can go up to 5,000 into plus of, or into multiples of 5,000. We can say 10,000 or 15,000 or 20,000. So what are the different application available or are used in the market. If you see mid-size mezzanine stores, which is generally from 5,000 up to 5,000, 500 to 5,000. And drive-in store where people call it as distribution centers, anywhere between 250 to 10,000 metric FC cold rooms. And we will see these details in the presentation. As I was saying, this is a typical, 250 metric ton small mid-sized store with ground plus first floor storage. And this is typically used by individual trading companies. They have one particular product they import, or they do like apple or maybe dried fruits. They import apple, or they import any special biscuit kind of things, chocolates. So they use this kind of stores. And even some people store like what you call this good, the sugar in this. So it will retain its color throughout the year. And we have people who store grapes. So these are typically for a single product, small mid-sized companies they use, and they do some processing also. And so this is the size, what we call it, mezzanine store, ground plus one. And next is the large stores. Typically, these stores are in the rural areas, if you see, mostly for storage of bulk bumper crops like mostly potato, pulses, you have chilies, and you have any major spices like your turmeric, tamarind, and you have sugar in bulk stores, even dried potato chips. And if you talk about dried pulses, most of the pulses also they store in this. So this is generally, if you talk about the minimum room size, will start anywhere between single room of 750 metric ton and multiples. So if you have 750 metric ton to 4 or 6 chambers, and sometimes the people go up to even 2,500 metric ton single chamber into 2. So this is an economical solution for a bulk backend stores. And most of these stores, as I said, before 15, 20 years, they used to be done with civil construction. Now they are going with civil pillars, but the entire cold room is exposed cold room, where there is no civil wall done, only some safety walls are constructed only up to 3 meters or maybe 2 meters at the bottom level. The entire top panel is exposed. And they generally in the height of in the levels of ground plus 3 or ground plus 5. This is what is the configuration is. And next is the driving cold rooms, or we call it as the palletized cold room, where you have forklifts which can load the product and unload the product, and vertical height of up to 10 meters. Typically, these kind of cold rooms are used by major distribution companies like Coldman, Snowman, Western Farm Fresh. So, and the advantage here is that in a smaller space, you have a vertical height of 10 meters, and the construction cost is less because there is no civil work, much civil work involved. Directly, you can see the truss, or we can call it as a racking system, where the product is stored on directly onto that. So this is basically used for in the consumption points and shipping locations like Chennai. You see all the port cities have these kind of cold rooms, which are mostly operated by the distribution companies or logistics companies. And next is, as I said, finished food store, where you have a process plant. After you do all the processing, like if you see, this is a typical fish fillet processing project, where the fish get cleaned. It's a pre-processing area, and it gets processed in trimming line. Then after that, they do further processing, and they freeze it, and it comes to the packing area. Then it is stored. This can be applied similar analogy can be given to a seafood processing plant, poultry processing plant. So all these plants, after they do the process, they have a store where they store the producers. So these stores are again, bulk in size. Generally, if you look at, they go anywhere between 500 metric ton to 1,500 to 2,000 metric ton. Even bigger stores as per the production capacity. And if you look at the size or maybe the kind of structures used is nowadays they are going with the racking storages. And third is this is an interesting solution which people use it for spherical round products, especially where they call it as open store or maybe dump store, or they call it as bulk store, where the product is stored in an open cubicle where the air is circulated through a special passages created under the product. And typically the operators which are seen in the other cold room application, they are seen they are fixed to hold the air above, and there is a special circulation mechanism which circulates the air through the product. And this is specially used for products like potato, carrot, ginger. So where it is one product store, we can say. And mostly used for potato, which is processed potato in India. And much similar is the box store. This is again, the advantage here is the vertical height can be utilized totally. And this is again used for products like potato and mostly in India, but in outside countries they use it for other fruits, but in India it's mostly potato. And in terms of refrigeration systems, but till now we have seen what are the classification based on the user point or maybe the application in the market. And if you look at from the technical side, from our supplier side as a refrigeration contractors or maybe refrigeration designers, we have major classification of two. One is split system, other is central system. And with the recent development, we have one more addition where we have a scroll compressors, which is a new technology which is taking over, particularly in the medium temperature applications. So I will discuss more about medium temperature here, where chilling applications or cold room applications. And if you look at the split system, we have the smaller where you use it for small cold rooms, like where we have seen for restaurants and these kind of usages. And these are sealed compressors, which is nothing but hermetic compressors. And next is slightly bigger capacities, or we can say up to 250 metric ton, 500 metric ton. We have a split system with sprawl. And next we have semi-hermetics, bigger capacity, you can go up to 1,000 metric tons. Then we have the rack, that is multi-compressor system with sprawl, which can be used for 5,000 metric ton kind of stores. And in the same range, we have the semi-hermetic system. The advantage in semi-hermetic is you can use, and we have systems for low temperature as well as plus temperature. But if you look at the past 5 to 10 years, this scroll is occupying more space in medium temperature application because of the advantage of cost as well as power consumption. We can see these details in the next slides. This, as I said, split system with the sealed compressor. The biggest advantage here is if you talk to any user, it is very easy to convince them. You can show 10 applications in the same town. Maybe you'll find any remote town today, you will have at least 10, 15 programs using this. So it is easy to convince ready-made solution available. As the user point of view, or maybe if you look at can it cover the entire range? No, it has limitation. Bigger capacities, we cannot go for this. You can go technically, but you'll have multiple units, which is not advantageous. And next comes, as I said, the central system where you have multiple cooling points connected to one central refrigeration system, where we have two classifications. One is semi-hermetic. I have shown both the pictures in this for simplicity. So either you can have a semi-hermetic or you can have a stall compressor in this. And this is typically a air-cooled, so nothing but the condenser. And in all these kind of central system, we use a split condenser. That means the condenser is separate, or we can call it a remote condenser. So the condenser is air-cooled. So as I said, advantage here is the capacity. You can handle large capacity in this. It is flexible. Okay, you can have some different temperatures. You can operate 2 rooms at 2 degree, another 4 rooms at 8 degree, or 4 degree, or 5 degree, like that. So it gives you that flexibility because it's a central system and we have a large condenser, and it automatically takes care of the catering to the load. It's an efficient system. In terms of ruggedness, yes, it has all built-in safety because the one-to-one split system, you cannot incorporate all the safeties, which is cost-wise not feasible. But in central system, we can build that. A lot of extra safeties like oil management and voltage controls. So all those things can be easily incorporated in this system. Customization, as I told you, like if you want 100 kilowatt or 250 kilowatt, 280 kilowatt, as per your need, it can be customized. Even you can have a built-in standby. So you have a 250 kilowatt, your peak running load, and you need to have an extra one compressor, you can put in like that. Or you say that within the capacity, you had a built-in capacity that can be done. So those kind of customization possible. And next to say is easy to operate. Okay, people will say there is always a counter argument. But for a capacity of maybe 300 or 500 kilowatts, if you look at the number of one-to-one split units versus these, it is easy to operate. Same system, the only change is your condenser is water cooled. As I said, it gives you the flexibility. You can connect any kind of condenser you like, unless in a split system which comes in a package from the factory. Here, you can fit the condenser the type of condenser as per the resource available. If you have water, you go for a water cooled condenser. So this flexibility gives you an advantage that as per the site, you are doing cold room in Rajasthan, certainly maybe there is a water shortage, or maybe in a city location where there is a water shortage, you can give an air-cooled system. And when you are doing it in a remote locations where water is available, in an agriculture area or rural locations, easily you can go for a water cooled solution. Broad discussion on this. As I said, it's easy to install split system if you look at faster delivery because it's a ready-made product made by any factory. So you say 10 kilowatt into multiple, you can buy that. And as I said, easy reference available, any location, anywhere you can show it to a customer. And if you look at the disadvantage, if you have 10 units, you have to have 10 foundation points. You need to give supply to 10 points. And invariably, mostly these split systems are air-cooled. So it consumes more power. And after a certain amount of time, like initial 1 or 2 years, we may not have that pain, but when the days goes on, your maintenance cost increases because there are multiple units, multiple location, multiple components. So the failures and component maintenance increases. And any modification, suppose you say that today my load is 10 kilowatt, tomorrow by reason it reduces to 5 kilowatt. How do we handle that? There is a challenge with these kind of things. And other way around, you say that I want to add some more, then you have to buy a package and add it. There's no other option in this. Whereas in a central system, as we discussed, the overall aspects, but the main important point, suppose you say that I have a 200 kilowatt system today, and I find that due to certain reasons, maybe the type of product or the type of incoming temperature, you find there is a lot of spare capacity available. Maybe you come to know this after 2 years of operation, or due to some change in your input condition, there is an excess capacity available. You can add some cooling units, extend the piping, the same outdoor unit or the same compressor system will cater to this, which is a very big advantage. Particularly, we have seen this kind of usage in cargo complexes where the import-export cargo is handled. Their plan changes very drastically from the point they conceive or they start the project to when they end the project. So for those kind of users, this is very, very useful. So we could see that without changing the backend, we are able to alter their room size changes, their room layout changes. So all these things can be easily managed when you have a central system. In terms of, you'll ask what is the problem or what is a disadvantage or maybe a limitations here. Of course, you have to, when you customize, delivery time is going to be more. So you have to plan when you plan the project. When you have to do some maintenance in terms of annual maintenance, or you have to take up a breakup, you need some expertise to do maintenance on this central system. Next comes your important point. Mostly this is a point of discussion. Most of the users have these exact numbers, and we have studied and we have found out in actual numbers also matches to this. So the first set, if you look at, these are for semi-hermetic system. You compare with a condensing unit, that is plate unit, what is the power consumption? On the right hand side, if you look at the total number I have given, for 100 kilowatt cooling, what will be your power consumption? So if you look at condensing unit, air cooled, almost 32, and down you go up to ammonia, 21. And if you come slightly above, it is 25 kilowatt for a rack water cooled system. So this is typically for a medium temperature application where the bulk product stored in the range of 8 degree to 4 degree. The next comes interesting point. When you use the sprawl system in the similar situation, we can see a rack or the central system with the water cooled, our total power consumption is very close to this ammonia system. And if you look at the air cooled, it is almost equal to semi-hermetic. So there is no much difference. So you use semi-hermetic or scroll, it doesn't matter when you are using an air cooled. But when you see a water cooled system, particularly for these kind of bulk stores, where traditionally a lot of people used to go for ammonia, now a lot of people are changing. Even we, after working in last 10 years plus in this segment, we could see users are accepting and they are finding it useful to go for this technology. So this is basically about the bulk store, the refrigeration options or maybe systems design available for bulk store producers. And I will show you some of the important kind of projects we have done where we will see this bulk store also there in that. So if you have any questions, maybe Chris, I think we will be noting and I think we'll answer that. And typically we have done like packers for ammonia, much similar, using much similar technology, sprawl. Then meat product, value-added product, semi-hermetic system, and 2,500 pallet store or food processing unit, and multiple applications in dairy, like 5 lakh liter milk store, ice cream plant, ice cream hardening room plus storage rooms. And as I said, like curd is an important aspect which is picking up or which has come into the market recently. So that again, we have done a lot of curd projects. And as we were discussing the bulk store, this is a typical application for a bulk store with a scroll water cooled rack. This is the exact application. where we have used this technology for last 4+ years. It is running. The oldest is running for more than 6 years, you can say, with water cooled application. And others is like pack hoses. Again, this also we have done it with a similar kind of technology, and where they look for a optimum cost solution, because semi-automatic becomes a little limitation there. So scroll fits in very well in that aspect. And, next, our favorite item or what we have worked on is the snow amusement parks, where we have done more than almost nearly 6 projects completed now. And over a period of time, we have developed some expertise. Very interesting application what we have developed, learned, and maybe we have fine-tuned our solution to that. Hence. And next is the vaccine manufacturing, where we have expertise or maybe learned to fit in the product properly to their need. This is a typical pictures of snow parks. So as I said, 6 projects completed. So these are some of the pictures. And here again, we have experienced using the split system and the central system, air cooled, water cooled. And in the off late, we have done some projects with heating of a swimming pool using the waste heat from the snow park or a water park, integrated water park and snow park. So the waste heat from the snow park is heating the swimming pool of the water park. As I said, some of the applications what we have done, and same thing, some pictures. This, as I told you, pre-cooling application where we have done one of the biggest pre-cooling with scroll central system. In this project, the entire products is made in India. That is the beauty of the project what we have done. I think I am coming to the end of the presentation. So
we have few interesting questions, sir.
Yes, sir.
Okay. Mr. Shankaranarayanan wants to know, like, there's a thumb rule for calculating the heat load for an air conditioning project, 150 to 250 square feet per ton. He wants to know, do you have similar kind of a thumb rule for calculating heat load for our cold room requirement? I have the answer, but you please go ahead and give him the answer, sir.
Okay. Sir, we can, it is there. It's not that it is there. But only thing is based on, suppose you have a 10-meter store or like this multiple level store, we have one number. And if you say your cold room is 3-meter height, that number changes. So it is there, but it is not universal like in air conditioning, because air conditioning is little more where you can say the parameters are more fixed, so they are able to get that number. It's not like that we cannot get it. We have that number, but only thing is it keeps changing based on your height of the room. And second is category to category. Suppose you say I am storing potato, it's different than if I am storing pulse. So there is something called product load which changes. So the number changes due to various variables, but there is a number we can do that.
Fine. Mr. Natarajan Swaminathan wants to know, is there a practice of pumping ozone gas into the cold room to improve product finish and increase storage life?
Sir, maybe I've heard something like this, but what's practically done in the industry is nitrogen blanketing, what they call it as CA store or modified MA store, modified atmosphere store. So nitrogen blanketing is done, but ozone I have not heard about much.
Excuse me.
Maybe people might do it.
Excuse me, here I can feed my information regarding ozone in cold storages. We have been using this technology for last 15 years in cold storage for sanitation and the order removal.
Okay.
Yeah, thank you.
Mr. Shankar Narayan wants to know what is the requirement of such bulk store business potential in Chennai? Where and what capacities? It's more of a commercial interest. Yes, I still leave it to you.
Okay. So Chennai, as I said, it is a commercial hub. So as you know, you have operators who are operating cold rooms for logistics, like Snowman, Western Farm Fresh, I think Phil Fresh, or I don't know, I hear some other names also there. They're like more of a port logistics and local logistics. So this is there. But if you talk about F&B or bulk stores, Chennai will not be right, because Chennai is not a producing place. So bulk commodity stores may not be that viable, but you will have a distribution, because being Chennai being a consumer point, can have a store of 500 metric ton, 200 metric ton into 4 chambers, 3 chambers, like that. You will be able to, because you will find multiple application or multiple products coming into a consumer point. Like you will have butter, cheese, which you need to have a separate chamber, and you might have pulses and sugar and those kind of things can be a separate chamber, and the egg kind of things may be a separate chamber. So not exactly bulk store of what you have for a produce store like potato, but mid-size, small-size stores can be there for local consumption. There is a market.
There's an interesting question from Mr. Javed. He wants to know, as an air conditioning market in HVACR industry is about 85%, and refrigeration market is only 15%. So he is asking us how to encourage people to work in refrigeration industry.
Sir, it is a challenging question. It's a challenging situation also, which we are into. Correct. Yes, as of now we can say, if you look at compared to 20 years before, there mostly it was ammonia backend stores, or mostly ammonia based application, and very limited market size. Market has grown, of course, yes, and as you know, even though the 15% we say, but still it is a good size market today. But only thing is, what we find today is that since this is more of a customized solution, people should have that inclination to work on, work with hands and to deliver a customized solution product rather than like an air conditioning, where is a more of a standard product. So finding people to work is really challenging. Is getting challenging. But how people are overcoming, or how we are overcoming, is try to do maximum work in the factory, make it like a finished product, package it, and reduce the field work. That's how we are managing today.
Mr. Ilaraja, last question. Mr. Ilaraja from Ilaraja Venkatraman wants to know, what is the typical cost of storing per kg per month for an evaporator temperature of minus 20 degrees Celsius? This is the question they should have asked Snowman. They're asking the designer.
Actually, yeah, this is, I think, Trish, I think everybody knows, the people in the trade will know this. It is like if you talk about stores like Snowman, they have some X number. Maybe I remember some before Corona, some 70s, 17 and 16, those kind of thing. I have that number. So they used to charge some maybe 3,000 plus per pallet. But whereas if you go to a store which is outside or maybe private, it can be 1,000 rupees per pallet also. So it's highly variable number depending on this. And if you take long-term lease, maybe they can change. This number will change.
Fine. I'm done, sir. For all the participants who have logged into the Zoom call, I have your database, and I'll share your database with Mr. Sivakumar, and Sivakumar will send you a thank you email tomorrow or day after tomorrow, depending upon his time availability. And then you can start communicating with him on all your requirements. A few of you are asking for some data or the PowerPoint presentation, which Mr. Sivakumar will directly send it across to you once he's once you have his contact details, or you have his contact details there in the presentation, Sivakumar@avplcoldchain.com. Please send your emails to him and he'll respond to your mail. Thanks, Sivakumar, sir.
Yeah, I should say that I should thank the team, Refcold team, for giving this opportunity. Thank you, all the participants, for
Question
spending
anyway.
the valuable time with us.
Raja, can you have a conduct a quick formal vote of thanks? Raja, are you there?
I can.
Yeah, Raja Sriramala, Raja NMAC.
Raja NMAC. Okay. Ask him to please. Go ahead.
Raja,
Sir, good evening. On behalf of Refcold 2023 committee members and History Chennai chapter, I thank all the members participated in this webinar. I believe this will be a very useful and informative webinar. I would like to express our sincere thanks to the speaker, Mr. Sivakumar, for delivering the wonderful speech. And I thank the Refcold committee members for organizing this webinar. One small information to all the participants in this group. This webinar series is planned once in every 15 days on the refrigeration segment. And we request all the participants to spread this series webinar to all your known contacts who are related to the refrigeration industry, and just spread the knowledge of this and get for the benefit of the people who are using who are the refrigeration industry users. And thank you all for joining for this webinar. Thank you.
Thanks, Sivakumar, sir. Thanks a lot. Thanks a lot for your effort.
Thank you, Chris. Thank you.
And thanks for all the participants for logging in and taking your time out. Thank you. Bye. Bye. Bye.
Thank you very much, sir.